Hello again everyone, welcome back to ptet.chemistry channel. So this is the last bit of this 14 to 16 years old chemistry tutorial. Well, chemistry in the sense that it's pure chemistry or single science chemistry, suitable for 14 to 16 years old GCSE, IGCSE, O-level or whatever curriculum that you're doing in that particular age range. So since I've gone through the idea of diffusion in terms of kinetic particle theory in the last lecture tutorial, so what I'll do in this particular tutorial is to go through a couple of questions associated with the concepts that we had covered previously. So here we have a student setting a tube shown in this diagram. These kind of questions are really popular in the sense that they involve ammonia. I talked about chemical formula in the last tutorial, in the last lecture tutorial. Ammonia has this formula NH3. It means there's 1 nitrogen and 3 hydrogen. What I haven't done was to introduce you hydrobromic acid, but as I mentioned, these are very popular setting for any kind of diffusion questions. What they will do is they will introduce you the idea of hydrogen chloride. Hydrogen chloride, as mentioned in the last lecture tutorials on the chemical formula, is HCl. When you dissolve in water, when you dissolve HCl gas in water, what you're going to get is you're going to get hydrochloric acid. So hydrochloric acid is a mixture. It's called HCl aqueous. So it's what you call a mixture, what you have learned in lower secondary. It's not pure substance. It's got HCl and it's got water in it. Okay, what happened with hydrogen chloride is this is HCl gas. This is HCl gas. So gas is represented by a square, well, by a bracket and then G for gas. And aqueous means dissolved in water. It's always a mixture. It's HCl and water being H2O. So what we have here is hydrobromic acid. If you have hydrobromic acid, it's actually HBr. So bromine, Br, is just below Cl in the periodic table. So if you can find Cl, you can find Br, which is just below it. In this kind of question, it's about diffusion. So, well, give or take, you can hopefully see the midpoint of this tube. If you started from here and here, this is the midpoint. So hopefully you can see that diffusion, the two gaseous particles will diffuse, but one has gone a bit further towards this side, and this has gone a bit slower, this has gone a bit faster. That's why the formation of the product, which is formed when HBr reacts with NH3, is that you will get a white solid forming closer to this end because the HBr travels slower because it diffuses slower. That's why you have the formation of the solid closer to the hydrobromic acid, because this diffuse faster, this diffuse slower. If you meet exactly in the midpoint, they diffuse at the same rate. If you meet closer to this end, it means this side will diffuse faster than this side. Okay, so this is essentially what the question is trying to tell you. They already tell you that you get a fumes of hydrogen bromide, which is just HBr gas. From this hydrobromic acid, even though it's concentrated, it's still dissolved in water. So it's just boiling off and giving you HBr gas. Aqueous ammonia, so it's the same thing. Ammonia dissolved in water. What you get is you get fumes. Fumes refer to gases. It refer to vapor. So all those things, vapor or fumes refer to gases. So gaseous particles will diffuse faster than liquid or solid particles. After some time, we get these forming at point X, which, as I mentioned, is much closer to this hydrobromic acid end as a result of this diffusing slower and this diffusing faster. We have to use kinetic particle theory. Again, a lot of students lose the marks. So these are 4-mark questions, a lot of marks on these. We need to talk about diffusion. We also need to talk about the rate of diffusion as governed by the relative molecular mass, something we have done in the previous topic called, not previous topic actually, in this topic, but in the previous lecture tutorial, I show you how to work out relative molecular masses. Look at your periodic table, use the relative atomic mass, sum up the individual, total up or add together all the individual relative atomic mass depending on how many atoms you have. All this was in the last lecture tutorial. So first of all, I need to have 4 points to get 4 marks altogether. We can see that there is diffusion. So the HBr and NH3 fumes. You can talk about fumes, contain gaseous particles. So basically I'm talking about the particles of HBr and NH3 that diffuse. The particles move randomly. So I'm talking about the essay on diffusion. The particles move randomly in all directions. But then we know that it's from a region. So the point number 2 is from a region of high concentration. That means, ammonia starts from here. This is where ammonia is highest in concentration. It will spread towards the region of low concentration for ammonia. On the other hand, this side has a lot of HBr fumes, and they will go from a region of high concentration of HBr spreading to the region of low concentration for HBr. So from a region of high concentration to a region of low concentration. And then the third point on diffusion is until the concentrations are uniform throughout. Until the concentrations, because it's concentration of these two particles and not just one thing, which is common for the previous examples. So uniform means it's the same throughout. So just like you wear a school uniform, everyone is the same throughout. Anyway, so the next point, really, there's only 3 points. We need to talk about why is it further to the left of the midpoint. We need to use the idea of MR. So I can probably say that HBr fumes, HBr particles are heavier, and I'll explain why it is heavier later on, because I will show the calculations. Heavier than NH3 particles. So therefore, HBr particles diffuse slower. They diffuse slower than NH3. If they diffuse slower, that's why you get this formation of the product when these two come together closer to the HBr end. Okay, so therefore X is closer to HBr. How do I explain this? It's not enough just to say it's heavier, because anyone could say it, but you need to prove it. So show your working. The MR of HBr, so this without the number shown at the bottom means there's one of it and one of it. So there's one hydrogen. The mass of each hydrogen is 1. In the periodic table, you have 1 and 1. This number at the bottom is given in the periodic table. They call this relative atomic mass. If you read the legend in the periodic table, which of course you need to know how to read it by now. So bromine has got 79 at the bottom. I forgot what number it is on top. I'm actually not looking at the periodic table right now. But then I've used, not 79, it's actually 80. I've done enough chemistry in my entire life that I know that this is 80 for bromine in your periodic table. So I've got one bromine. Each bromine is 80. So that is the mass for each bromine. And then I need to show for the other one. Ammonia, as you know from the name, you need to know the formula. There is one nitrogen. That's why there's no number shown there. And there's 3 hydrogen. Each nitrogen has a mass of 14, because this number on top is not the relative atomic mass. This number on top is the identity of the element. It's called proton number or atomic number, as given in the periodic table, as stated in the periodic table, which is given in the real exam. The number at the bottom for nitrogen is actually 14, because it represents the relative atomic mass for one nitrogen atom. And I've got 3 hydrogen atoms. So altogether I got 17. By showing this working, I made my point that HBr is heavier than NH3, and therefore HBr particles will move, it will diffuse slower, and therefore, since this is traveling faster, this is diffusing faster, this is diffusing slower, the meeting point is going to be much closer to the heavier end, which is hydrobromic acid, the HBr there. So there's kinetic particle theory, talking about the particles, okay? Now the next thing is, if I use hydrochloric acid, so this question is saying, if I repeat it, but I use hydrochloric acid, what happened to the position of X? Would it change or would it not? Okay, there are two bits to this question. Describe and explain. And again, kinetic particle theory. What happened to the particles? If I use HCl, HCl is basically the formula for hydrochloric acid. This is aqueous. As usual, just like the hydrobromic acid, the concentrated or the hydrochloric acid will give you fumes of hydrogen chloride, HCl gas, which was covered in the previous lecture tutorial. So HCl gas. So what happened is, I need to show the MR of HCl. So the formula for hydrochloric acid is HCl. The MR for HCl is going to be 1 hydrogen and 1 chlorine. In your periodic table, you got 17 and then 35.5. This 35.5 is the relative atomic mass for 1 chlorine atom. There's 1 chlorine atom and there's 1 hydrogen atom. So 1 hydrogen atom, each one has a mass of 1 in the periodic table, as shown there, relative atomic mass. From your periodic table, you got 35.5 for 1 chlorine, and you have 1 chlorine atom there. So 1 times 35.5, the mass is 36.5. What I'm going to do is I'm just going to copy that, but then you should know how to write this again. So the MR of HBr very clearly is 80, and since we are still using the same NH3, so you know it's still the same NH3 that is being used, still the same NH3 gas. So MR and H3 was previously your 17. Okay, so I could, you know, copy paste that instead of having to redo it again, or you could just write MR or NH3 is just 17 as previously obtained already. So this is still heavier than this, so this will diffuse slower than that, but this is heavier than that. So this question is not on the NH3, it's on HCl versus HBr. That is the idea, HCl versus HBr. So what do we know here? HCl particles are lighter, or you can say HBr particles are heavier, but it's not important, well, it's not enough just to say the point without showing the working. These are very important in the working. So now I'm just explaining. HCl particles are lighter than HBr particles. So the lighter you are, you diffuse faster. So HCl particles can diffuse faster. If they diffuse faster, they will travel a bit longer distance, which means that they will travel faster than HBr, they will diffuse faster than HBr, which means their meeting point will not be at X. It will not be at the midpoint because remember the MR of HCl, it is still heavier than 17. If the HCl is still heavier than 17, it will be, you know, before this midpoint, it will be closer to the heavier end, but it's lighter than HBr, so it will be slightly, you know, slightly towards there. So this is the new X if HCl is used. It is still, HCl is still heavier than NH3 based on our calculation, but HCl is lighter than HBr, so X will be slightly to the right, but not passing the midpoint. Okay, so we will say X is, should probably use a different color ink just to emphasize my point. So therefore, X is going to be slightly to the right, slightly to the right of the diagram shown above. We want to be as clear as possible to the right of the diagram shown above, but still not passing the midpoint. Not passing the midpoint, as you know, as HCl is still heavier than NH3. So this is just whatever stated in the syllabus. Use the idea of relative molecular masses. Know that the lighter you are, the faster you diffuse. The heavier you are, the slower you diffuse. Okay. So this is going to be a slightly longer tutorial because we've got a lot of questions to go through. So let's move on. Here we have a half-filled syringe with water, and then we drew up some blue ink. So you suck up some blue ink. So this is the blue ink. This is water, which is colorless. Colorless, we don't say it's white in color. We say it's colorless. It means no color. You see through it. So this is your blue ink. You suck up some blue ink. and then you have a separate layer. That's the idea that they are trying to do in the question. Whatever you do when you read questions, you circle, you underline so that you could see in the question. Do not have a habit of just reading and doing. Instead, you read, you circle, you underline, and then you read again so that you understand what the question wants you to do. You left the syringe for 20 hours, so you do not mix them together. So you do not mix them together, but still, after 20 hours, what will happen is, you will have uniform concentration throughout because the color will have spread, the ink will have moved throughout. So what happened is, the blue color spread throughout. Use kinetic particle theory. What happened to the particles to explain these observations? Okay, so we know diffusion has happened for 2 marks. Sometimes it's 2 marks, sometimes it's 3 marks, sometimes it's 4 marks. We need to talk about diffusion. We need to talk about diffusion of liquid particles. Okay, so obviously it's slower than gases because liquid particles don't travel as fast as gaseous particles, but still diffusion will happen. So we know that the blue ink particles, so the blue ink particles diffuse throughout until uniform concentrations, uniform concentration, meaning the color spread throughout until uniform concentrations. I think probably I should have written towards the end there. Hang on, maybe I should just start off the essay first. So the particles move randomly in all directions. So this is without mixing, they just move randomly in all directions. So I first talk about diffusion or diffuse throughout, they move randomly in all directions. And this is from a region of high concentrations, which is where you suck up the ink, to a region of low concentration, which is the remaining bit of the colorless water, to the region of low concentration. And the very last point, which is basically the observation, which I have asterisk above, the ink has spread throughout the water. So what's very important is until uniform concentrations are reached, or until the concentrations throughout become uniform, until uniform concentration is reached, because we just have one substance here rather than the diffusion question in the previous bit. Now the next bit of the questions, you repeat this experiment at a higher temperature. We did say that liquid particles don't have as much energy as gaseous particles, but if you use hot water, for example, or you heat up the ink a little bit, you do the reaction, you repeat the reaction at higher temperature. So describe and explain. So again, there are 2 points to it. What happened to the particles? That is called kinetic particle theory. Any difference in observations? Well, the question did say after 20 hours, the blue color spread throughout. We know that as temperature increases, so as temperature increases, what happened to the particles? We know that temperature is a measure of your average kinetic energy, how fast the particles are moving. So we talk about the ink particles. The blue ink particles gain more kinetic energy. So when we talk about kinetic energy, we talk about their movement. So therefore can move faster. So if they move faster, can diffuse faster. I should probably say can move and therefore diffuse faster. And if they diffuse faster, therefore the time taken for the blue color to, if we read back the questions, it says the blue color spread throughout the water. So we're talking about the rate of diffusion, the time taken for the blue color to spread throughout. So basically the rate of diffusion is faster. If the rate is faster, the time taken for the diffusion will be much shorter than 20 hours, much shorter than 20 hours above. Okay, so hopefully it makes sense there. I have described what will happen. The time taken will be shorter. Explain why. The rate of diffusion is faster because I talk about what happens to the particles in terms of the kinetic energy, and therefore they travel, they diffuse at a faster rate. Next question. This is a kind of multiple choice questions. Could be a structured question. Very, very interesting one. So what happened is we have A. A particles, which consists of 78% nitrogen, nitrogen existing as this molecule, 2 atoms of nitrogen, and then we have 21% O2, and then we have 1% other gases. You have learned this in lower secondary science as well. Porous means the gaseous particles can go in and out because they have got small holes. They call pores, P-O-R-E-S. So the oxygen is inside, which means the oxygen can go in and out like that. But then we also have air outside here as well. So which gas, when present in the beaker over the porous part, will cause the water level to rise? If you want the water level to rise, if you want this one to go up, I should probably use a different color. If I want the pink color to go up, this has to go down. If this has to go down, I have to have more gaseous particle inside, because at the moment it's level, because the number of particles exerting pressure is equal to the pressure being exerted downwards. That's why the pressure down here is equal to the pressure here. But if I want the pink color to happen, I want it to go up, this has to come down, then this will go up. The reason for this to come down is when there are more gaseous particles. So to get more gaseous particles, inside the pot. Okay, so what must happen? What do we want? We want more gas to diffuse in faster than the oxygen gas could diffuse out. So we want more gas to diffuse in at a faster rate than oxygen inside, which is the oxygen inside here, can diffuse out. If we want a faster rate of diffusion, so we want it to diffuse in faster and therefore add to the amount of particles inside, then you can exert more pressure downward and this will go upward. What must happen? We want to diffuse in faster, so we are not changing temperature. Remember that temperature can affect diffusion, the last question, but we are not changing temperature. What we are doing is we are changing the particles, which are CO2, CO2, CH4, and NO2. These are given as formulas, so you suspect is to do with MR calculations. You want faster rate of diffusion, so you want the MR to be lower. Lower than what? Lower than oxygen. If it is lower than oxygen, it will diffuse in faster than oxygen can diffuse out. So let's work out the molecular mass for option A. MR of CO2, as you know, is the sum of the relative atomic mass. We did this in the last lecture tutorial, so you can find out what I'm trying to do here. So this is the mass of 1 carbon, and I have 1 carbon. This is the mass of 1 oxygen, as shown in the periodic table, is for 1 atom. So you have 2 atoms, so I multiply by 2. You do that in your calculator, you get 44, and then the MR of CO2. Each chlorine is 35.5. I have 2 of it, that's 71. It looks like I have to work out for all of them. Well, do I? I have 1 carbon, and then I have 4 hydrogen. So 4 times 1 there, I get 16. I'm pretty sure the answer should be C, because you have oxygen in the air. The oxygen in the air is O2 and not oxygen atom. So that's 16 times 2, which is 32. So you want it to be lighter than 32 so they can diffuse in at a faster rate. They like to ask this in structured questions. So make sure show the 2 MR and then talk about the rate of diffusion inside into this space here must be faster than the oxygen can diffuse out. We want the gas going in to be lower mass than O2, which is already inside. I think we already got the answer as this CH4. You can work out for part D, nitrogen monoxide, which is going to be 14 times 1 plus 16 times 2, which is going to be 32 plus 14 is 46. But what I must warn you is you only have 1 minute for each multiple choice question. 1 minute. You only have 1 minute for every 1 mark in a real O-level exam. So you need to be able to read very fast and therefore think about strategy, and therefore you must know your syllabus very, very well. This is the last bit in this topic, lecture tutorial, and these are just series of questions which I decided actually would be good for me to go through some of these to show you how to navigate through real exam questions and how to address exam questions. This is talking about kinetic particle theory. Talk about what happened to the particle. Do not miss the big idea. Describe. There are so many lines and 2 marks. If you just write one word, you're not going to get any marks at all. You are not writing a marking scheme. There's no point of Googling the answer. What you must do is you must know what the syllabus, what the learning objectives say candidates should be able to. If you're still referring to your notes as you're doing your exercises, you will never improve. That's why you should have gone through the notes, review the notes, write on a piece of paper based on the objective, and therefore learn how to do things on your own. This is changes in the movement. That is part 1. Changes in the arrangement. Changes could also be, thinking about compare. This is another word, the one, compare the movement and arrangement. So when a solid becomes a liquid, so this is to do with melting. This question is not asking you just on solid. It's not asking you just on liquid. It's asking you what has changed. First in movement, first in arrangement. You could do a solid, liquid, and then movement and arrangement, something like that. But what I'm going to do is I'm going to split it out into movement first of all. We know that solid particles, so this is about particles because it's kinetic particle theory. We know that the solid particles vibrate about fixed positions. But what about liquid particles? So liquid particles can move, but then they can only slide past each other. So liquid particles have a greater degree of freedom. They don't move freely in all directions, but they can slide past each other at a slightly faster speed than just normal vibrations. The second point, which is on arrangement. Arrangement, how are they arranged? How are they packed? So I can talk about solid particles are regularly arranged. So they have a regular arrangement. They are orderly arranged. Ordered arrangement, you can talk about ordered arrangement. And they haven't really asked on separation, which is how far apart they are. So this is just regularly arranged, ordered arrangement. I think I don't need to talk about tightly packed because they haven't asked about packing. It's about arrangement. But just to be safe, I can just say tightly packed. I think that pretty much sum up every single thing that I want to talk about solid particles. Whereas the next thing, liquid particles are only closely packed. And then I can say disordered or with no regular arrangement. So there's no particular pattern when you talk about liquid particles packing. Okay, so that's it really. Just the 2 marks is you need to talk about comparison. It's not just solid, it's not just liquid, it's describe a lot of lines just for 2 marks because 2 main points, but for 1 point it's served to get the marks. You need to have both solid and liquid because it's about the changes from solid to liquid, from solid to liquid. Be very careful when you read questions. If there is anything you are less happy about or unclear, then feel free to raise up any doubts rather than you moving forward without knowing how to break that question. Thank you for watching, and do follow me at ptet.chemistry, at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram to get connected. So I'll see you in the next tutorial video. Thank you for watching.